Okay, part four. Thanks for hanging with us. Here's Kristof again.
Okay, thank you, Matt. Here we go. We're on part four of our four-part series on VRF mechanical systems. This one is on outdoor and indoor units. I want to preface by saying that this is an overview, as all of these talks have been, of what can get very complicated and nuanced set of mechanical systems. I'm trying to highlight and give you the lay of the land of this equipment. So let's jump right in. We're going to start by talking about outdoor units and then indoor units. In the outdoor unit space, there are a range of different styles, form factors, and of course manufacturers there. You can see there's several. Carrier, Toshiba are working together, Fujitsu, LG, Daikin, Mitsubishi, I think. Maybe some more represented on this page. Top left, you see some commercial units. Just down below them, there's a water-cooled unit. There's some residential units on here. Let's just get into it. Despite the differences, at the core, there's the same functional component, and it is not this Copeland scroll. I'm just using that as an illustration here of a compressor. Most of these manufacturers actually make their own compressors and their own control components. But functionally speaking, there's the same core here. It's a variable frequency compressor combined with the variable refrigerant LEV or EEV on the indoor unit, sometimes on the outdoor unit. Let's talk about some of the outdoor units now, the broad categories. So we have single-phase heat pumps on the left. Typically, those are for residential or light commercial applications. In the center, we have heat pump or heat recovery systems. These are three-phase systems, and there's an example there of a single module that's been twinned. You sometimes also get triple modules. The three-phase systems start at 6 tons, which you can see, except for the three-phase. It's some residential applications that would be fine in terms of capacity. They're bigger, but they're not too big to put near a house. All of these exceedingly quiet. We'll be looking at that in a second. Third category is water source heat pumps and heat recovery equipment. Again, the sizes and the three-phase could be considered predominantly for commercial applications, though not impossible for residential, but we'll talk about converting from single to three-phase in a moment. What I really want you to take away from this slide is that there are heat pumps, whether they're air or water source, and then there are these units that they refer to in the industry as heat recovery systems. Heat recovery means they can provide simultaneous heating and cooling. It's a very exciting, very efficient way to move heat and cooling around a building, especially if there's a lot of diversity in the building, which many buildings have, a lot of commercial buildings particularly. So let's start by looking at the three-phase heat pump systems. These are air source. I put a little picture in there showing scale. They're fairly large. They can go on a roof. LG has one of these that can breathe right through the sidewall of a building. That can take its intake and exhaust air right through the sidewall if you want to preserve your roof. I would imagine other manufacturers are looking at that same capability. It seems like a great idea. So this is the heat pumps. These can either be in heating mode or cooling mode. They can go 6 to 24 tons in a single module. You can also, of course, put multiple modules. And so the sky's the limit in terms of capacity here. Next thing you have is heat recovery systems. So similar form factor, internally some differences. These typically have some sort of branch controller or a three-pipe system in place. But the focus here for you now should be that for you to recognize that these systems offer the ability to have simultaneous heating and cooling. This can be a big deal where stack effect heating could be occurring, or where the perimeter of a building needs to be cooled, and that means that the center core of a building is needing heating. The heat that's being rejected in the areas asking for cooling can be sent right to the areas asking for heating, and the outdoor unit is essentially acting as a pump in that situation just to move the refrigerant around. So same applications, same considerations go into these multi-zone heat pump or heat recovery systems that are water source. Again, these are three-phase now. And the capacities go from what could be a big residential application to as big as you need. There are many applications now where we are looking at the possibility of converting single-phase power in a residential system or a light commercial context to three-phase power so that we could run one of those three-phase systems. There are known applications where a phase converter has been used to convert, in that picture there, I have a single-phase panel and create three-phase output to run one of these. There seems to be, scratch that, there is some lack of clarity on the side of the manufacturers as to whether that's okay with them. So consult with your manufacturer, consult with your application specialist to make sure that they're good with that. Little confusing to know that it's been done and yet the manufacturer states, well, we're not sure you're allowed to do it. So either it works or it doesn't, and the manufacturers should decide whether they're okay with it or not. There are single-phase VRF water source systems. Water Furnace 7 Series, Climate Master Trilogy 40 are probably the only two that I know of. There could be others out there, but certainly locally here I've heard of these. These are very forward-looking systems. They are still limited to that one-to-one mode. So in a big house, you're running a big system and you are reliant on airside zoning, which could be said to be somewhat defeating a little bit of the potency of the VRF product. But there are single-phase, one-to-one VRF water source heat pump systems out there. Talk to me more about this before you jump into one of those. There's a lot more to say here. We need to keep moving. So if we get centered on the residential context, which is probably where a lot of you are, it's definitely where I'm finding my focus right now. We have two main types. We have the single zone and the multi-zone. Right? We have what I refer to as mini splits on the left and multi splits on the right. Mini splits go down to, I have 3/4 of a ton. They can go even smaller. They can go down to a half ton on there. And multi splits are typically in the 1.5 to 5 ton range. Different form factors, many different manufacturers. I'm showing Mitsubishi here. I'm going to show it on this next slide too. Keep in mind, this is representative of a class of products, and many of these products that are shown here are repeated almost exactly in other manufacturers' product lines. So what we're seeing here is systems that go from around 1.5 tons on the left, and you can connect 2 outdoor units to it, to 4 tons on the right, and you can connect up to 8 indoor units to it. So we have 1 outdoor unit, and we can go 2, 3, 4, 5, or 8 indoor units. All of these outdoor units are going to be extremely quiet, low vibration. The applications they're growing out of in Asia are these units would be sitting on the balcony, and the balcony of your apartment is probably your only private outdoor space. So keeping it quiet was a high priority. Low energy using, extremely reliable. Here's some examples of installation. They're light and compact. They can be wall mounted. They can also sit in the standard way. They can sit on a pad. You can put the refrigerant lines in the wall, or you can run them through those plastic conduits. Here's another application where we have 2 of the, I believe those are Mitsubishi S-Series outdoor units, both wall-mounted, one above the other. Might be some considerations about when the upper unit defrosts, it might dump some water onto the lower one, but that shouldn't really be a performance issue because these units are outside and water landing on them is not a problem. Extremely quiet. There are definitely requirements as to how you're allowed to stack these and align them, and you do need to allow for good airflow, but those requirements are not stringent. It's typically 3 to 5 feet away before you can put an obstacle. These outdoor units are where most of the brains, most of the technological changes that separate VRF equipment from conventional equipment are. So these outdoor units are definitely where the complexity lies and where some of the additional expense that comes into VRF installations occurs. There's also, well, we talk about some of the issues at the end here, so I'll just leave it for that. Very exciting technology for those of you in heating-dominated climates. Tube-and-tube heat exchangers, the variable frequency operation allows for extended ranges of heating capacities. Let's look at Mitsubishi as an example here. You can see they have what they call their hyperheat inverter, the hyperheat inverter H2I, compared to standard equipment or compared to their own non-hyperheat equipment. You can see you're getting into the low single digits in terms of degrees Fahrenheit before you have roll-off in delivered capacity. That's really exciting. Even in a hot, humid climate zone, there are possible applications for extended heating performance, specifically where you see lots of glazing, lots of walls of glazing. This can cause disproportionate heating loads over cooling loads because of the higher delta T's. So if you don't want to add supplemental heat, you're going to need to possibly look at one of these units. We talked about these units being very quiet, and here's an example. 19 dBA is astoundingly quiet. I would encourage anybody listening here, just go to the App Store on your Droid or iPhone and search for a sound pressure meter. Or you can email me, I can recommend a couple. But you can put it on your phone, you can monitor the sound in the space where you are, and you'll be surprised to know that what you consider a quiet room is probably in the 40s, the mid 40s, in terms of dBA. So all of these units are relatively quiet. We've talked about some of the benefits. Most of these benefits are associated with the outdoor units. Efficient part load performance, they're very versatile, very quiet. You have a lot of different control options. They have the ability to, because they have the ability to deliver efficient part load performance, they give you high levels of comfort. Obviously, reducing the need for ducting is almost always a good idea if you can do it. And then there's the longer run times, which means more filtration, more mixing, and more latent control, improved latent control. We have multiple independent indoor zones as opposed to airside zoning. Refrigerant side zoning can be completely independent. Many of these units are ventilation compatible, and for the most part, there's high reliability and low maintenance, though that's coming out of manufacturer literature. I'd like to see more third-party documentation on that. Bottom line here on these VRF outdoor units is, as someone in the industry, whether you're an architect or a builder, or if you're a homeowner, put this into the conversation in terms of your high-performance design. The range of efficiency improvements is across the board. I've seen a number of studies, again, a lot of them by manufacturers. Several, though, third-party studies. I really believe we need to do more of these, and we're involved in one now. I'd say the center core is probably the 30 to 40% efficiency improvement range over conventional equipment. All right, next we're going to jump into talking about the indoor units. Here we're showing several of the main types, and we're going to be talking about them individually. One way to relate to these is as a palette of colors. A palette of colors meaning you can paint more and different ways to deliver comfort to your indoor space. On the right there, that gray box, that's a very standard form factor. It's roughly 2 by 2 by 4 foot tall, and it can go vertical or horizontal. That could be a fantastic opportunity for a retrofit. The lower left, we have a concealed ducted unit, kind of like a stack of 4 pizza boxes, and in terms of form factor, and the air would flow from right to left in that picture. And then just above it, we have radiator style and concealed ceiling units, and then we have the classic that's associated with all mini multi-splits of these wall units. But the bottom line, what's really important about this is that all of these can deliver truly independent zoning. So one of the things about that is they're very space efficient. Instead of using that big duct to move your conditioning fluid around, you're actually using those very tiny refrigerant lines to do that. So as I mentioned, these are very space efficient. Instead of using ducting to distribute the heating and cooling fluid, you're using refrigerant lines. And one consequence of that is you don't need the space for the ducting, so you could possibly raise the ceiling. Let's look at that again. If you don't need to allow space for plenums and ducts in the ceiling, you could possibly raise the ceiling. Alternately, you could keep the ceiling low and add another floor to the building and stay within height restrictions. That can be a big deal. Similarly, in the residential context, by using this range of indoor units that we're talking about now, you can avoid taking up footprint in your buildings with mechanical equipment. So there goes that ceiling again. Thanks to Keith Reel with Mitsubishi for that graphic. So let's jump right in and talk about indoor units. In the indoor unit category, there are three main types: space-mounted, ceiling-recessed, and concealed ducted. Space-mounted have been synonymous with this industry for years, and we'll see that they are definitely not the only offering. So in the space-mounted category, we have the familiar wall-mounted units. The wall heads are typically called. There are also ceiling-suspended heads, and there are floor-standing units. So in the wall units that are known well, there's a tremendous range of manufacturers, and these can be done in mini and multi-split configurations. In my market, we're still seeing these thought of as aesthetically impactful in a negative way. From a heating and cooling perspective, they are phenomenal heating and cooling machines. Though SEER is entirely inappropriate to quantify efficiency for VRF, it is out there as a point of comparison right now. I sure hope that changes soon. In SEER, though, in terms of SEER, these units can go as high as 30 SEER. So, and that doesn't really take in their variable capacity performance. Wall units, if you're a homeowner out there, you drive this decision, you tell your design team you're good with it, fantastic idea. Fantastic way to deliver comfort and very efficient performance to your house or to your project. So the next type is ceiling suspended. And again, we have some fairly consistent expectation that these are an aesthetic hit on the building, but these are phenomenal in terms of throw. These ceiling suspended units particularly have the ability to deliver long throws, 20 plus 30 feet across a space. So there's some bars in Austin that I've seen these mounted in. Getting into that aesthetic hit, at least one manufacturer, this is LG here, has given a nod to, people don't like the way these space-mounted units look. And they have trim kits for their wall heads there on the left. They also have this line they call the Art Cool, where you can put in whatever artwork you want, and then when you turn the unit on, you can see in that center picture at the top right there, the unit has tilted forward a little, and these little ears have opened on the side. The tilt forward is the return coming in through the top, and then the supply is out the side. And you can see there that you can put whatever artwork you want. So that's pretty cool. So also in the pretty cool category are these floor standing units. These are radiator style. They could go into a building where there used to be radiators, and now you have heat pumps. Where the water lines used to be, you put your refrigerant and condensate lines. Simple, retrofit, fantastic. Look at that one at the bottom there. Again, a range of manufacturers, range of styles in terms of sizes and capacities. That bottom one is uncased. Here's another example of an uncased system. It can be built into a wall cabinet there. So you have the return at the bottom. You would open the cabinet doors to change the filter or service the unit, and then the supply is out the top. Do not overlook the impact of these simple floor standing units. For instance, look here, we have a graphic of a return at the bottom, and we have the unit in there in green and our supply ducts going out the top of a built-in cabinet. So let's say you have a residential project where you have a flat roof assembly, or for whatever reason you don't want to put ducts in the roof, and you have this living room, dining room, kitchen, central core of the home, and you're not sure how you're going to deliver heating and cooling to it. Well, look, if you have this cabinet or you build in a site-built cabinet, you could have just delivered space conditioning to the center of this space, and all you needed to provide access for was refrigerant lines, condensate lines, and electric power. So very exciting opportunity, not to be overlooked. Okay, so the next of the 3 broad categories are ceiling recessed. And again, this is representative of a class of products. There's typically small and large 4-way cassettes, and then there are 1-way cassettes. Main difference between the small and large 4-way is that the larger ones, all the service can be done through the faceplate, whereas the smaller ones, typically you need to provide a separate auxiliary service access port off to the side. The 4-ways can have up to 2 of the 4 directions shut down and then ducted to an auxiliary space. This could be fantastic for like a master bedroom with the cassette, and then you put the auxiliary duct to the master bath. These units can receive ventilation air. The 1-way cassettes, I know of whole homes that have been designed to have these 1-way cassettes in them. 1/2 ton to 1.25 tons on there. So probably one of the more interesting or exciting and the third category of indoor unit type are these concealed ducted units. And there's a bit of an urban myth out there that's saying, oh, you can't duct a whole house off of these. They don't have the static pressure capability. And that's not true. There are units that have low static pressure capability only, and you need to be very cautious and just make sure you're paying attention to your plenum design and your trunk and runouts. But there are also medium and high static systems in this category, and they go from 1/2 ton to 8 tons. So you certainly could duct a whole house off of one of these units, although putting a whole house off of one unit would somewhat negate the fact that multi-splits, one of their performance features is multiple independently zoned indoor units. This concealed ducted category is just replete with entrants. There are manufacturers, I could probably have found 15 different manufacturers to show here, but they're very similar in terms of their form factor and in terms of their performance. Here's an example of one installed. That shiny part on the bottom right, that's the bottom of the unit. It goes into a plenum, it's up in a ceiling space, and then it goes into supply trunks. Daikin has something called their Daikin zoning kit, which is pretty cool. It's like a front end that goes on their concealed ducted unit, and then you have dampers that'll serve different spaces, and here's the dampers, and each of these dampers is controlled by its own thermostat. So you can have one indoor unit. Keep in mind, you could have 8 of these concealed ducted units in your house, and then you could put this on one of them and make 4 more subzones for 4 offices or 4 bedrooms or 4 separate rooms in the building. So that's pretty exciting. And then this one should not be underestimated, the impact of this. This is a very familiar form factor. These vertical, they also can go horizontal, but they're typically referred to as vertical ducted units. They have a range of static pressures. Definitely you can duct a whole house off of one of these or an entire zone. They can go vertical or horizontal. They can incorporate ventilation air. They have the ability to be using standard pleated media filters. So I would say from the installer side, this is the exciting tool to get familiar with, because it's not going to be unfamiliar to you, right? You're going to put refrigerant line, condensate line, and power. You're going to put your filters and your plenums on it, and off you go. It's just like what you've been doing for forever now. Okay, so we talked a little bit about variable capacity and inverter drive, and there are actually really exciting technologies that are moving beyond this. I know that manufacturers are offering laced segmented coils, or coils where one segment can be in defrost while the other one's still in operation. That's just tremendous. The ability to vary the effective surface area of your indoor and outdoor units really allows you to expand your performance. And that should actually probably wait for a different conversation. Again, very quiet operation on these indoor units. Here are the ones that are compatible with ventilation air, right? So pretty much all of them, though not in all sizes of all of them. All of this equipment generally, indoor units and outdoor units, is associated with low energy use. Here's one quick way to quantify this. Looking at the indoor units for conventional, typical units are 6 to 12 amps. Some of the smaller units are only using 3 amps. Compare that to VRF. Look at that. It's like a light bulb on an indoor unit, and it goes up to about 400 watts. So very low energy use. Outdoor units, typical one, my 3-ton at my house comes on at 40 amps. Comes on at 80 amps, and then it cruises along at 40 amps. VRF equipment is coming on 2 to 3 amps. Its peak will be around 25 amps. When I measure these in the field, once the house has reached equilibrium, even in the middle of a hot afternoon, they're pulling 3 amps. So very low energy use. The amp draws are going to correlate to the power, and there's similar power factors across the industry there. So let's talk a little bit about efficiency. I mentioned that 30 SEER. SEER is rating equipment at 1 load factor, and it's full load. AHRI has a standard. There's standard 1230 2010 for the performance rating of VRF equipment. I encourage you to look at this. In that standard, they essentially say that they expect the full capacity rating to be valid for around 2 to 3% of the hours of the year. And other than that, you're going to be looking at part load metrics, which are going to be in play. I don't understand why, but the part load metrics are only applicable to equipment with capacities more than 5 tons, more than 65K BTU specifically. Hopefully that'll change going forward. Part load performance is a very important consideration for all of us to be familiar with, and our current metric, SEER, doesn't help with that. So let's recap and do a quick wrap up here. I think this is a fairly interesting set of ideas I've collected here. What are the issues? What are the concerns that we would face with VRF, with this variable capacity equipment? One of the main issues is actually market inertia. The market is where it is. It's moving gradually this direction, but currently it has a lot of inertia in the conventional equipment direction. Partly that's because of a pretty pronounced lack of third-party measured performance data. We're working on some studies with Thermistor and Risinger Homes, and I would love to see more studies. I'd love to see more third-party measured performance data. Everybody installing a VRF system, I would love to find a utility program or some application where you can get measured performance, where you can be measuring at least the amp draw from your indoor and outdoor units. Cost is another differentiator here. These units typically cost more. There's 2 things to say about that. One is that there's some increases in cost associated with lack of familiarity on the part of the installer. And there's also generally, just speaking generally, the value in terms of budget that is typically given to a home's mechanical system is a bit distorted. It's a bit small. Basically, you have an enclosure and you have a mechanical system, and those 2 deliver performance in terms of comfort and health and safety and indoor air quality and energy efficiency. And yet that system, that mechanical system budget, is often relegated to a distant 4th or 5th place after many purely aesthetic considerations. Not that aesthetics aren't important, but function is something that, core function of your mechanical system is something that it's not easy to upgrade later. Robert Bean at healthyheating.com has some fantastic information in terms of what might be expected, what you might expect to pay for a good mechanical system as a function of build cost. So I mentioned installer service and training, right? This is important and changing. I know these classes are filling up, and that's great. Let's see it going that way. These units can be seen as increasingly complex and having difficult scenarios for service. Similarly, they can be seen as offering tremendous benefits for the service managers and the service guys in the field because of the tremendous amount of data that comes out once you connect your laptop to one of these systems. Controls, I think, is an area where there's a lot of low-hanging fruit these manufacturers are going to be starting to pull, specifically with integrating with dampers and remote access, web-based access. All the manufacturers need to be moving there as quick as you can. You can't say, oh, here's your high-performance mechanical system for your high-performance home, but I don't know, good luck integrating your ventilation damper with my controller. I can't help you. That's not realistic. Neither is saying, here's your high-end residential system, but you can't get to it from your iPhone unless you buy this multi-$1,000 controller. Just not realistic. Not paying attention to market demands and cleaning the coils, costly to service, another common issue I hear out there. Bottom line on that one is we should be changing our filters. We should be doing regular maintenance on our units. And if you don't, it does cost money to take care of that. I would like to see these units, which have the opportunity for enhanced latent control, I would like to see them actually measure and control based on latent loads. Most of the units currently don't. There are a couple that are out there doing it. So that's some of the issues, and happy to discuss those in depth. If you have questions, please send them along. Let's talk about the benefits. Well, we've talked about this one, efficient part load performance. That's huge. I can't stress enough. Your home is almost always under part load. You need a system that can operate efficiently under part load. That's why we're here. That's why we're looking at this equipment. In terms of the palette of colors on the indoor units, tremendous versatility is given to the designer. And in all cases, you're going to be delivering much more precise control of the indoor environment and resulting in better comfort. Independent indoor zones, these units are very quiet, reliable, they have longer run times. You can read the rest of these here. Ventilation is compatible with them. Bottom line is variable loads are a fact of life. Weather is constantly and incrementally changing, and the loads inside our buildings is always changing, and we need to be able to meet that with variable capacity. And as I've said several times, my main goal, I think Matt and I are in agreement here, our main goal in terms of delivering these podcasts is just to put VRF in the conversation. Okay, thank you again. Look forward to hearing your questions. Here's our contact information. Take care. Bye, everyone.
Hey, I just want to say a special thanks to Kristof Irwin and his team over at Positive Energy. He spent a ton of time putting these slides together and doing this podcast style 4-part series. Thank you, Kristof, and your team. Amazing work you guys do over there. I love working with y'all. And I know this was a huge time suck for you, Kristof. If you made it to the end of this 4-part series, you are one of us. You are a true HVAC geek. Of course, for more information, you can visit my blog at mattreisinger.com. I'd also love to have you follow me on Twitter. And, of course, you can visit our company Facebook page as well for photos. Thanks for joining, everybody. We'll see you next time.